So, ionic bonding. It's not letting me type it up. Is huge numbers of atoms participate. Electrostatic attraction forms crystal lattice. Formula unit, simplest ratio of repeating pattern. That's not really important. They have very high melting points because of the strong attraction. And they conduct electricity only when dissolved in electrolytes. So, let's understand the 5 characteristics of ionic compounds. So, because basically, a lot of your tests will probably be about ionic compounds. So, you know that it's, Alright, so these are the 5 characteristics. You know it's a metal, non-metal bond. Electrons transferred from cation to anion. Remember which one's the plus? Cation, anion's the minus. Strong bond is a very strong bond. It's the strongest, I think. And it forms a crystal lattice, like I said in the past few slides. And it has a high... What the frick is MP? I don't even know what that means. I wrote MP down, and I don't even know what that means. I'm so dumb. It's definitely not so. Melting point. Sorry. Melting point. Know this. This is possibly going to be on your test. Sorry about my handwriting. My handwriting is really bad on here. So, now we're going to go into polyatomic ions. So, do you happen to know what a polyatomic ion is? Well, if you don't, it's a covalently bonded atom with an overall charge caused by excess shortage of electrons. So, basically, what that definition is saying is that when atoms bond, there is sometimes an excess or shortage of electrons. So sometimes electrons are lost, and sometimes electrons are added. So that's why when you see O2 minus, that means that you're adding 2 electrons. When you see Li, 1 plus, that means you're taking away 1 electron. So that's what a polyatomic ion basically is. It's the taking away or the adding to a structure. More electrons. There's either more electrons or there's less. There's a shortage amount. So metallic bonding is I'm going to draw it in the transition metal. Tightly packed cations share valence electrons in the area. So this is metallic bonding. It's very tightly packed. Plus. that's, so you have, but you also need to draw little structures there. These are free valence electrons from outer shells of metal atoms. Alright? And then these are like metal ions. Obviously, as you can tell, because they're pluses. So they're metal ions, which are what? Cations. They're pluses. So this whole bonding, now we're on metallic bonding, not ionic, involves overlapping of an s orbital and d orbital electrons. And d orbital electrons p orbitals are empty. So s and d orbitals are bonded, obviously, as you can tell, and the p orbitals are empty. There's none left. There's no electrons left. So electrons are delocalized. They are delocalized, which means they don't belong to any one atom, but they move freely. Among cations, because that's what's in this case. The fast-moving electrons are why metals are good conductors and shiny. So they move fast, which means good conductor. So cations in tightly packed crystal lattice, are forming the strongest bond type. So when they're in a crystal lattice and they're tightly packed, as in this case, it is a very it's a strong bond. Alright, now I'm going to explain to you. I don't know if you learned this, but I sure did. There is a way that you can draw a Lewis dot structure for an ionic compound. So the way So you have one cation and one anion. So if you have CaF2, you have one cation and two anions. So it would look like this. Ca2 plus 2F. Remember, it has to have the octet minus. Now when you have two cations and one anion, like Na2S, this is the plus, this is the minus, so that's the cation, that's the anion, cation, anion, you get 2Na plus and plus, sorry, this is supposed to be a plus. S. Well, let me draw. Alright, there you go. So that's that. So basically, your cations don't have a Lewis dot structure around them, but your anions do. They have a full octet. Because they are adding electrons. Remember, they're adding electrons, the other ones are losing. They're adding, so they had to have a whole octet, so might as well show the whole Lewis structure. Alright, so we don't have to go over Lewis structures, But, here, I have something here for you. So if you had to describe the theory of metallic bonding, you better put down Paul Drude. His theory was for sorry, I just hate this stupid oh my god. Alright, so alright, there we go. So that can be erased. Alright, so covalent bonds are bonds between nonmetals to form a molecule. So let's write that down. Covalent form molecule. Just not a speller today. Atoms involved share, keyword, share electrons for octet, like we showed in the last one. Alright, so the this is basically, memorizing it, writing down notes, understanding it. You should make like a flip chart, something, so you understand the difference between the types of bonds that I'm explaining in this video. You should write down or understand different characteristics, because this is the covalent. I know I wrote down the ionic, and I know I just wrote down the metallic, so you should know the differences, because those will be key words on the test. Key things that you'll have to know. Electronegativity difference between the elements is low. So, as you can see that this one is a molecule, so the question is, what is a molecule? Well, a molecule is a group of atoms held together by covalent bonds, because like we just said in this last slide, they form molecules. So obviously, this is going to be held together by covalent bonds. Ionic compounds do not form molecules. Ugh, I hate this thing. Right? They do not form molecules, but form crystal This is for ionic, by the way. Okay, so don't get those confused. Know that covalent bonds make molecules. Ionic have many atoms, but they do not form molecules. Okay? And ionic is the strongest. Know that too. And I'm pretty sure you know that because I knew that you knew that. So there's different types of covalent bonds, and they all depend on how evenly charged they are distributed. I don't know if you remember the picture